Welcome to Sanwibe Science Foundation. Today, we will be looking at Waec 2025 Practical Chemistry Alternative B. We'll be looking at quantitative analysis, question number 2. To begin, let us look at what we are given in the specimen. In our specimen, we are given two substances to analyze. One, calcium triazocarbonate 4, and the other one is sodium chloride. We will look at the preliminary test of these two samples. Their physical appearance is that they are white powder. Their salt is soluble in water, while calcium triazocarbonate is not soluble. So we are required to mix them in equal amounts. So if you mix them, they will give you a white crystalline or powder mixture. If we now check the cations that are present, we have calcium ion and sodium ion. If you undergo a flame test, you see that sodium ion gives a bright yellow flame and calcium ion gives a brick red flame. And when we talk about solubility of the two salts, for calcium triazocarbonate, it is insoluble in water. However, it can react with an acid to make it more soluble. For sodium chloride, it is very soluble in water. So sodium chloride is soluble in water. All right, with this background, now let us start the main analysis. Remember, we are required to put them in equal amounts, mix them together so that they become one substance. And this substance is known as F. Let us start. The question I have here is a question I organized to see that this work is well analyzed. It is my own mindset. Don't mind if there is any variation in the exam hall. But for now, let us read the question. F is a mixture of an inorganic and organic substance. Carry out the following exercises on F, record the observations, and identify any gas or gases involved. State the conclusion you draw from the result of each test. A. I put all of F into a test tube or beaker and add about 10 cm cube of distilled water, stir, filter, and keep the residue. B. I test the filtrate with litmus paper. II, to about 2 cm cube of the filtrate, add few drops of silver nitrate followed by nitric acid. Then add ammonia to the resulting mixture. C. Put all of the residue in a clean test tube, add about 5 cm cube of dilute HCl or nitric acid, shake to dissolve, divide into two portions. To about 2 cm cube of the solution from 2Ci, add sodium hydroxide in drops and then in excess. To another 2 cm cube portion of solution from 2Ci, add ammonia in drops and then in excess. Now these are the questions I have prepared so that we can analyze this. Now let's see the analysis. All right, here is the analysis. We are required to put all of F into a test tube or beaker, add about 10 cm cube of distilled water, stir, filter, and keep the residue. So if we do that, we add F to 10 cm cube of distilled water. F will dissolve partly, giving a colorless filtrate and white residue. Our inference is that F is a mixture of soluble and insoluble salts. The next question, BI, test the filtrate with litmus paper. If we test the filtrate with litmus paper, no visible reaction occurred. That's our observation. So we conclude that F is neutral, or F is neither acidic nor basic. The next is to about 2 cm cube of the filtrate, add few drops of silver nitrate, followed by nitric acid, and then ammonia. If we add silver nitrate, we observe white powdery or chalky precipitate. So you can write white powdery precipitate formed or white chalky precipitate formed. The inference, chloride ion, CO3 ion, or SO3 ion present. If we add nitric acid to it, the precipitate remains insoluble. You can write precipitate insoluble or precipitate does not dissolve. It's an indication that chloride ion is present. Then if you add ammonia, the precipitate dissolves or becomes soluble. So it's an indication that chloride ion is present. Now, the C part of it says put all of the residue into a clean test tube and add about 5 cm³ of HCl or nitric acid, shake to dissolve, then divide into two portions. When you add HCl, effervescence occurs, colorless, odorless gas evolve, gas turns lime water milky. The gas is CO2. That is an indication that triazo carbonate 4 ion is present. I will tell you why HCl is most preferred to be added to this residue by the end of this class. All right. The second question says to about 2 cm³ of the solution from 2Ci, add sodium hydroxide in drops and then in excess. If you add sodium hydroxide in drops, white chalky precipitate is formed. This is an indication that calcium ion or lead 2 ion is present. If you add it in excess, the precipitate remains insoluble. It's an indication that calcium ion is present. The last question, to another 2 cm³ portion of solution from 2Ci, add ammonia in drops, then in excess. If you add ammonia in drops, no visible reaction will occur, no precipitate, or you can say no precipitate. So either you write no visible reaction or you write no precipitate. This is also an indication that calcium ion is present. Remember, the residue is more of calcium triazocarbonate 4. So it do not react with ammonia in any form. So if you add in excess, no precipitate forms, but as you keep adding, the solution becomes slightly turbid. So it is another indication that calcium ion is present. So we can say calcium ion is confirmed. So this is the analysis of the salt. Let us now why I said that HCl is the most preferred to be in that solution. Now, this is the reaction that occurs when each of the acids, HCl, nitric acid, sulfuric acid, is added to the residue. Remember, the residue is calcium triazocarbonate, while the filtrate is mainly sodium chloride, because sodium chloride dissolves purely in water, while calcium triazocarbonate do not dissolve very well. Now, if you use HCl, all the products will dissolve. So this can say that it is suitable. You can use best for it. But if you use nitric acid, all products will dissolve also. We can term it good. But if you use sulfuric acid, not all of them will dissolve, especially this calcium tetraoxosulfate 6 will not dissolve because it is fairly soluble, and then it may form a PPT. So we're actually saying that HCl is the most appropriate acid because it fully dissolves calcium triazocarbonate into soluble calcium chloride, as you can see from this equation. It does not produce any interfering precipitate, and it is standard in qualitative salt analysis. But we have to avoid sulfuric acid, using it to dissolve the residue. This is because dissolving calcium triazocarbonate in quantitative analysis will produce this calcium tetrazoate sulfate 6. This substance is fairly soluble, is not soluble, and it will reprecipitate, leading to incomplete dissolution and interference. So based on that, sulfuric acid should not be used to dissolve calcium triacylcarbonate 4. All right, the analysis. Thank you for watching. Don't forget to subscribe. Follow for more content. Thank you. Bye.